So this is the circuit for the half wave rectifier. Rectification means converting a AC pulse to DC. Alternating current to direct current. So which DC? It is not a straight line DC form, a pulsated DC form. So this is the circuit. This is a half wave rectifier. What is the meaning of half wave rectifier? Yes, this is the primary coil of the transformer. This is the secondary coil. Whenever an AC voltage is supplied to the primary coil due to the electromagnetic induction, so this mutual induction plays the key role, and this AC current is shifts to the secondary coil, and this secondary coil is connected through a load resistor and diode, where diode is forward biased to the input. So if this is the AC supply, AC is varying from positive scale to negative scale. If the current is in the positive scale, because of the forward bias connection of the diode in the circuit, there is a possibility for the yellowing the AC supply. But whatever the reverse pulse, see, this is the negative one, okay, negative scale of the bias. In this case, as the connection is forward, this negative scale values don't be allowed. So only from here to here it is a full. So 0 to 2 pi, one phase was finished. So actually it is a reverse phase in the opposite order. So complete phase was finished. Only half phase is converting to the DC, half phase. Whatever the remaining phase, it won't be converted. Still some AC distortion will be there. That is said to be ripple factor. Means suppose if AC current is totally converted to DC also, at some points or some peaks, there is a possibility for the residual AC source. So this phenomenon is called ripple factor. So in this case, we can expect the ripple factor, because these waves which are in the negative phase won't be converted to DC. So such like that, the graph will changes in another way. So this is called rectification. So how much AC current is converting to DC? This point is very, very important. This is called efficiency of the half wave rectifier. What is the efficiency of the half wave rectifier? Efficiency means the ability to convert the AC current to DC. So in this case, what we can understand is some 40.6%. That means some 100 volts of AC current was supplied, 40.6 is converted to AC, remaining some 59.4 will be AC only. So only 40.6% is converting to DC. So still this 59.4 is ripple factor. So this point is a very, very important one for this rectification. So across the load resistors, when the AC is traveling to the load resistor, it should convert it to DC. Only that DC wave is allowed due to the positive approach or positive connection or forward bias of the diode. So like this, we can see the graph of the half wave rectifier. Suppose this is the input AC. We should write the waveform. This is, let us suppose, an input AC waveform. whenever this input AC waveform is connected, in the positive half cycle, it will allowed through the load resistor. In the negative half cycle, there is no current. That's why it won't be allowed through the resistor. That's why only positive peaks will be appeared in the output also. The lower peaks, these peaks won't be appear. So what will be the output DC? So what about the lower peaks, the negative half cycle peaks? So before this one, I explained some ripple factor, means still there is a possibility for the residual AC because it is not totally converted to DC. So we can expect the ripple factor in this form. So like this, if this is input AC, this will be output DC. A pulsated DC, still an ability to focus with the AC current. So this is said to be a half wave, a rectification or half wave rectifier. Next, suppose if these low peaks, the negative phase peaks also should be converted to DC, that there should be another device we should construct. That device name is full wave rectifier. So this is a full wave rectifier. See the circuit. Yes, as usually the transformer core, and this transformer core is connected to an AC source. This is the primary coil. This is secondary coil. See, for the secondary coil, the positive sides of the, means P side of the diodes, both the P sides are connected to the ends of the secondary coil. The N types or the N side of the diode are connected to the common output terminal across the load resistance. So this center tapping is produced to convert the phases into positive and negative. So primary coil is connected to the AC source, and the to the secondary coil through induction the current will be shifted. So both the diodes will convert the AC to DC to the rectification. Why it is called as full wave rectifier? In half wave only the first phase will be rectified. In the full wave both the phases will be rectified at the same time. So if in the negative phase, let us suppose in the negative phase, because of the center tapping, this will be closed and this will be opened. So in case of that, positive won't pass any current because of the reverse bias connection. So whenever this is not possible to pass the AC current through the output across the load resistor, then the diode too will act to consider that and to pass to the load resistor. In the positive half cycle, because of the center tapping, if this is closed through this one, it will pass. So like this, in half cycles, maybe positive or maybe negative, through the both the resistors, the current will transferred across the resistors, and you will get the output. So diode 1, diode 2, both will act as a rectifiers. So there are two rectifiers, that's why it is called full wave rectifier. So this full wave rectifier converts mostly 81.2% to DC. This is efficiency. The efficiency of full wave rectifier is 81.2% and exactly twice of the half wave rectifier. This point is very, very important. So if one is in the positive half cycle, what is the reverse bias, second well will open and it will be converted to DC. If one is in the reverse bias, the another one will be open and that will be converted to DC. Like that we will get the efficiency waveform. And what is the structure of the waveform as an input and as an output, we will see now.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.